Hi everyone, my name is fellow David Adese. I am a fourth year software engineering student at Lakehead University. On this project, I worked alongside a fellow software engineering student, Sushant. And before I proceed to the demonstration of what exactly was built, I'd like to start off with a brief description of the project itself. I'd like to explain what we did, the problem we tried to solve, and also our thought process on how we solved the problem we identified in terms of the general system design for the project. So we built a machine learning web application capable of determining the eligibility of welfare applicants by classifying each household into specific poverty severity classes. Now, it operates based on descriptive information such as the ownership of durable items in the house, the observable household characteristics like the energy source, the electricity source, the method of trash disposal, the quality and conditions of walls, roof, and floor material, and also the quality of life in the people of the house helps provide an evaluation for the system as well. Now, this whole idea of using such descriptive information is called a proximity test, and a lot of countries use this already. Now, the proximity test is commonly used in welfare operations such as poverty reduction schemes, uh, student loan programs, food distribution schemes, health insurance, hospital fee waivers, and shelter provision. Now, the reason why such systems haven't been really effective in terms of poverty reduction for most countries is because the system still suffers a high likelihood of inaccuracy, and this is because this is due to the inclusion and exclusion errors that the system hasn't been able to avoid. Now, when I say inclusion errors, I mean false positives, and when I say false positives, I also mean non-poor people being classified as poor. And when I say exclusion errors, I mean false negatives, and that means poor people being actually classified as non-poor. And the result of such problems is that we have people who are supposed to be benefiting from social programs being excluded from the programs, and people who are not supposed to be benefiting from such social programs are actually benefiting from the program. So the whole idea is to create a system which can accurately identify the priority population in need of welfare resources, and this can help us ensure that the allocated funds provided by the government is effectively distributed during welfare operation programs like this. So in terms of the system design, we have a different server for hosting our web application. We also have a different server for hosting our machine learning model. And then we also have a database for holding information regarding the users and information regarding the analytics from the machine learning model. In terms of the system functionalities, we have functionalities designated for administrative users and functionalities designated for basic users. By administrative users, I mean agency members who process the applications, and then we have by basic users, I mean household members who actually submit the applications. Um, the first step to developing the system, we had to create a machine learning model in Python, and we were able to achieve an accuracy of about 93%. And then after that, we had to integrate this model into a web application whereby we can provide a user interface for users to interact with this model and run predictions. So the first step for our demonstration is for us to log into the system using household member information, and then we're going to create an application and submit an application, and then we're going to have to re-log into the system using an administrative account, and then we would process those applications so we can understand what the system is designed to do fundamentally. So first off, I'll log into the system using a household member account. As you can see, I already have an application already submitted. So the first thing I like to do is delete this application and create a new one. When I create a new application, the information asked are the features actually utilized by the machine learning model to process its predictions. So right now, I will just start off with some random values for the meantime. As you can see, we were able to submit an application successfully. Next up, I'd like to log out from this account and log into the system using an administrative account, and I should be able to process the applications that have been submitted. So right now I have 2 applications that have been submitted so far, and I can select both applications and check the eligibility of each application. So right now what happens is that I have no model deployed at the moment. The reason for this is because if I navigate to the analytics section and also to the manage models section, you will realize that we have no models deployed at the moment. And this is because we have 2 models pre-saved, but none of them have been deployed. So if I deploy this one, then I should be able to run predictions using the deployed model. So navigating back to the home section, I can select these 2 applications and check the eligibility. The model basically says both applications are not eligible for welfare, which is totally fine. But this basically tells us that the machine learning model is predicting that both applications are not eligible for welfare based on the data it has been trained on. So going back to the analytics section, another flexibility we have is that we can retrain a different model, deploy that model, and reuse that to analyze whatever applications that have been submitted. So if I select select the data set, and select the prediction algorithm, and a name for the data set, say a logistic regression model, I can save this model, and what happens is that it might take a few minutes to train, and then I expect the system to tell me when the training is done, and it should be saved into our pre-saved model section. So navigating to the manage model section, we should see that we now have three models already pre-saved into the system, and I can deploy whichever one I want to use. For the meantime, I would like to stick to the random forest model because of course it has the highest accuracy. And going back to our home section where we have all the applications, we can also decide to approve all the applications, switching them from pending to approved, or we can decide to disapprove all the applications. So basically the machine learning model doesn't really determine the final status of the application. It just helps the user come up with the most accurate prediction for that application. Maybe it should be disapproved based on the fact that they're not eligible for welfare, or it should be approved based on the fact that they're eligible for welfare. Another functionality included in this system is in the analytics section, is the fact that we can test the model that we are using. So how this works is that we have our data set right here. The first values here are the line numbers, and the last value here are the poverty classes. Now, poverty classes range from 1 to 4. So we have poverty class 1, poverty class 2, poverty class 3, and poverty class 4. So the poverty class 4 means the application is not eligible for welfare. Poverty class 3 means it's a low priority eligibility. Poverty class 2 means it's a mid priority eligibility, and poverty class 1 means it's a high priority eligibility. So the way we can test this system using the data set, just so you know, this data set is open in Notepad and just in plain text format, but it can actually be open in Microsoft Excel for better visualization. So how we test the model is that we enter the line numbers, and then we would compare the predicted value based on the actual values at the end. So I can enter a bunch of random numbers in here and test the model. And then the model should be able to tell me the line numbers that were predicted, the predicted values, and the actual values, and tell me if they're correct or incorrect. So right now we have all the row numbers we've entered into the system for testing. We can see the actual results and the predicted results. So far, out of all the rows we've predicted, we only had one wrong prediction, which is not so far off from the actual one. It was predicted to be ineligible, but it was actually a low priority household. So the fact that we have a lot of correct predictions shows that our system actually works at a high efficiency, or high accuracy rather, and it means the system is more capable of giving us a correct prediction for us to actually know whether to approve or disapprove the applications. So basically, this is the general idea of what the system is supposed to do, and thank you very much for listening.